this day Kalpana here. So in this video we are going to see a problem from Fourier series. So let's get started. Problem. Obtain the Fourier series expansion of f of x given that f of x equals to kx into pi minus x in 0 less than x less than 2 pi where k is a constant. So we are given a function, we have to expand it in Fourier series. Okay. And we are given interval 0 comma 2 pi, that is x belongs to open interval 0 comma 2 pi. Solution. Given function is f of x equals to kx into pi minus x in interval 0 comma 2 pi or ordered pair 0 comma 2 pi. The required Fourier series is f of x equals to a naught by 2 plus summation n equals to 1 to infinity an cos nx plus bn sin nx, where a naught equals to 1 by pi into integral 0 to 2 pi f of x dx, an equals to 1 by pi integral 0 to 2 pi f of x into cos nx dx, and bn equals to 1 by pi into integral 0 to 2 pi f of x into sin nx dx. Okay. Now first we will find a naught, an and bn. To find a naught, you know that a naught equals to 1 by pi into integral 0 to 2 pi f of x into dx. Now substitute f of x. We are given f of x equals to kx into pi minus x into dx. Here k is constant, so you can take it outside the integral. You'll get pi, k by pi into integral 0 to 2 pi x into pi minus x into x square into dx. So this is equals to k by pi into pi into x square by 2 minus x cube by 3 for x equals to 0 to 2 pi. Now we'll apply the upper limit and the lower limit. This is equals to k by pi into pi into put x equals to 2 pi. Simply we are applying upper limit minus 2 pi whole cube by 3 minus of, I put x equals to 0, applying lower limit 0 by 2 minus 0 by 3. So this equals to k by pi into pi into 2 square is 4 into pi square by 2 minus 2 2s are 4, 4 2s are 8 pi cube by 3 minus 0. So this equals to k by pi into 2 1s are 2 2s are, so 2 pi cube minus 8 pi cube by 3. This equals to k by pi into e to the 6 pi cube minus 8 pi cube by 3, which is equals to k by pi into minus 2 pi cube by 3 equals to minus 2k pi square by 3. Therefore, a naught equals to minus 2k pi square by 3. Okay. Fine. Now we'll find an. To find an. Now that an equals to 1 by pi into integral 0 to 2 pi f of x into cos nx dx. So this equals to 1 by pi into integral 0 to 2 pi kx into pi minus x into cos nx dx. So here take the constant outside the integral. We could write it as k by pi into integral 0 to 2 pi. X into pi is pi x minus x into x is x square into cos nx dx. Okay, now we'll use Bernoulli's formula. For integral by parts. Okay, integral u dv equals to uv minus u dash b1 plus u double dash b2 minus u double dash, okay, u triple dash b3 plus minus and so on. Okay, fine. Here u is pi x minus x square and dv is cos nx into dx. Simply we'll take pi x minus x square as u and cos nx into dx as dv. Okay, now we'll find u dash pi minus 2x, u double dash is minus 2, u triple dash is 0. So we'll take the first three terms. Okay, we'll neglect after u triple dash. So from here we'll neglect all the terms. Only first three terms we'll take. Fine. Now integral dv equals to integral cos nx. Simply integrating on both sides we'll get v equals to integral cos nx is sine nx by n. Again find v1. v1 equals to integral of v. So 1 by n into integral sine nx into dx equals to 1 by n into minus cos nx by n is equals to minus cos nx by n square. v2 equals to minus 1 by n square, that is integral v1 minus 1 by n square into integral cos nx dx. So this is equals to minus 1 by n square into integral cos nx is sine nx by n is equals to minus sin nx by n square into n is n cube. Okay. Is equals to k by pi into u into v. Pi x minus x square is a u into v is sin nx by n. Here we are using Bernoulli's formula, right? Minus u dash v1 minus u dash. U dash is pi minus 2x into v1 minus cos nx by n square plus u double dash minus 2 into v2 minus sin nx by n cube for x equals to 0 to 2 pi. Now we'll apply upper and lower limits. This is equals to k by pi into pi x minus x square into sin nx by n minus into minus plus pi minus 2x into cos nx by n square minus into minus plus 2 sin nx by n cube for x equals to 0 to 2 pi. Okay, now we can apply the limits. So this is equals to k by pi into, now apply the upper limit, x equals to 2 pi. Pi into 2 pi is 2 pi square minus 2 pi whole square is 4 pi square into sine n into 2 pi is 2n pi by n plus pi minus 2 into 2 pi is 4 pi into cos n into 2 pi is 2n pi by n square plus 2 into sine n into 2 pi is 2n pi by n cube minus, now apply the lower limit. Lower limit is 0, right? So x is 0, right? We'll put x equals to 0. So 0 minus 0 will be, obviously the first term becomes 0 plus pi minus 2 into 0 is 0, right? So pi into, you'll get cos n into 0 0 by n square plus 2 into sine n into 0 is 0 by n cube. Okay, since we know that sine 2n pi equals to 0, cos 2n pi equals to 1, sine 0 equals to 0, and cos 0 equals to 1. Okay, since sine 2n pi is 0, so the first term becomes 0 and the third term becomes 0. Here, last term becomes 0, right? So this is equals to k by pi into pi minus 4 pi is minus 3 pi into cos 2n pi is 1 by n square. Okay, minus pi into cos 0 is 1 by n square. So this equals to, no need of flower packets, right? So this equals to k by pi into minus 3 pi by n square minus pi by n square. N equals to k by pi into minus 3 pi minus pi by n square. This equals to k by pi into minus 4 pi by n square. Pi gets cancelled, so we'll get minus 4k by n square. Okay, for n not equals to 0. We got n equals to minus 4k by n square. Fine. Now coming to b. We know that bn equals to 1 by pi into integral 0 to 2 pi f of x into sin nx dx. 1 by pi into integral 0 to 2 pi f of x. We are having f of x equals to kx into pi minus x into sin nx into dx. Okay, so this is equals to 1 by pi. So k is constant, right? We can take it outside the integral. We'll get k by pi into integral 0 to infinity. Sorry, k by pi into integral 0 to 2 pi into x into pi is pi x minus x into x square into sin nx dx. Again, we'll be using Bernoulli's formula. Integral u into dv equals to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus minus and so on. Okay, so we'll take this as u and this as dv. U equals to pi x minus x square, u dash equals to x minus 2x, sorry not x, pi minus 2x, u double dash equals to minus 2, u triple dash equals to 0. Since we are having u triple dash equals to 0, so the terms from u triple dash will be neglected. Only will take us 3 terms. Fine. We are having dv equals to sin nx into dx. Integrating on both sides. By integrating on both sides, we'll get v equals to minus cos nx by n. Then v1 equals to integral of v equals to minus 1 by n into integral cos nx into dx. This is equals to minus 1 by n into sin nx by n equals to minus sin nx by n square, and v2 equals to integral v1. So you would write it as minus 1 by n square into integral sin nx into dx. So this equals to minus 1 by n square into minus cos nx by n, which is equals to minus into minus plus cos nx by n square into n is n cube. I get bn equals to k by pi into u. See, now we are applying Bernoulli's formula, right? So firstly, uv. U is pi x minus x square into v is minus cos nx by n minus u dash pi minus 2x into v1. v1 is minus sin nx by n square plus u double dash minus 2 into v2. v2 is cos nx by n cube. Okay, for x equals to 0 to 2 pi. So this equals to k by pi into pi x minus x square into minus cos nx by n, minus into minus plus pi minus 2x into sin nx by n square minus 2 into cos nx by n cube for x equals to 0 to 2 pi. So this equals to k by pi into, now apply the upper limit and the lower limit. Firstly, we'll apply the upper limit, so we'll get pi into 2 pi is 2 pi square minus 2 pi whole square is 4 pi square into minus cos n into 2 pi is 2 n pi by n plus pi minus 2 into 2 pi is 4 pi into sine n into 2 pi is 2 n pi by n square minus 2 into cos n into 2 pi is 2 n pi by n cube minus, now apply the lower limit, 0. That is, we'll put x equals to 0, right? Then we'll get pi into 0 is 0. Again, we'll get minus 0. So 0 into minus cos n into 0, 0 by n plus pi minus 2 into 0 is 0 into sine n into 0 is 0 by n square minus 2 into cos n into 0 is 0 by n cube. Okay. this is equals to k by pi into, since we know that sine 2n pi equals to 0, cos 2n pi equals to 1, sine 0 equals to 0, and cos 0 equals to 1. Okay, so here we are having sine 2n pi, right, which is 0. So this total term becomes 0. And here you are having sine 0, which is 0. So this term becomes 0. Okay, so here we'll get 2 pi square minus 4 pi square is minus 2 pi square into minus cos 2n pi by n minus, okay, you are having cos 2n pi value, right? Cos 2n pi is 1. So I'll get minus 1 by n. Okay, minus 2 into cos 2n pi is 1 by n cube minus, this term becomes 0 since you're having 0 here. We'll have only one term, that is minus 2 into cos 0 is 1 by n cube. Okay, so this is equals to k by pi into minus plus 2 pi squared by n minus 2 by n cube minus into minus plus 2 by n cube. So minus 2 by n cube and plus 2 by n cube gets cancelled. So this is equals to k by pi into 2 pi squared by n, which is equals to 2k pi by n. Therefore, bn equals to 2k pi by n. So now, substituting a naught, an, bn in f of x. Okay. By substituting a naught, an, bn in f of x, we'll get the required Fourier series. You have f of x equals to a naught by 2 plus summation n equals to 1 to infinity an cos nx plus bn sin nx. We have f of x equals to kx into pi minus x equals to a naught. You're having a naught equals to minus 2k pi squared by 3 by 2 plus summation n equals to 1 to infinity into an. You're having an equals to minus 4k by n square into cos nx plus bn 2k pi by n into sin nx. Okay, so this equals to minus 2k pi squared by 2 into 3, here 2 gets cancelled, plus summation n equals to 1 to infinity into minus 4k into, okay, 4k by n square into cos nx plus 2k pi by n into sin nx. Okay, see here you're having k common in this two terms. So you can take it outside the summation. So this is equals to minus k pi square by 3 plus k into summation n equals to 1 to infinity minus 4 by n square into cos nx plus 2 pi by n into sin nx. Okay, so therefore kx into pi minus x equals to minus k into pi square by 3 plus k into summation n equals to 1 to infinity minus 4 cos nx by n square plus 2 pi sin nx by n is the required Fourier series. So this completes the problem. So we have seen a problem from Fourier series in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.